Okay, hello. So let's have a look at today's update. So here you can see I've scaled the game up a little bit from just a box to a whole level. We can walk around. We've got collision checking. And yeah, that's it at this point. We've got some visual kind of quirks going on. So as you can see, this wall is to the left of the player, should be behind the player, but when I spin around, it comes in front of the player. But on the whole, I'm not too worried about that because what I'll be doing ultimately is running this in OpenGL and not this kind of handmade system that I just coded up. Because the handmade system's fun, but it's not what we're going to be doing in the end. Okay, so that's it. Let's have a look at how our system works. All right, so the big one is we have this function here, import data, which opens a file and reads in the data. So here's the file that we're reading. I designed this level by hand, just pen and paper. So each of these calls, W means draw a wall, and I've labeled these as well because that will make it easier to debug the system. P is to make a player. Okay, great. So let's have a look at the thing. So the way this works, this with means basically open the file and name it F, so that's the handle to the file that's been opened, and then execute all the code in this block, and then at the end of the block automatically close the file, because normally you'd have, open file, do stuff, close file. This is just shorthand for that. Okay, so we want to loop through every line in the file, but we don't know how many lines there are. We could do this a different way. So we could have something like okay, so call read lines, that reads everything as just a single block, and then go that, and that will loop through every line in the block. But let's say, for instance, for one reason or another, we want to do it this way. We might not know how big our file is, and loading it in may be too much for the system to handle, so we just process it one line at a time. Okay, right. So based on whether our line starts with a W or a P, then we either create a wall or player object, and now we've got this list called walls, and that will just keep track of all the walls in the game. So when I create a wall, I append it to that list, and then in the update we go through, for wall in walls, update, and that handles everything. The reason that, so I've got this, find the opening bracket and the closing bracket, and you'll find that I've actually copy pasted it down here for the player as well. The reason I'm doing that is we could have gone into our level and say we don't want to, or say we want to just do a comment. We can do that. And that doesn't start with W and it doesn't start with P. So the line doesn't get read and the loop would just continue. But if I pulled this, start and end out to the front, so I was reading that no matter what, I would reduce the amount of code that I've got, but it would be failing because when you write a comment with no starting and ending brackets, it, it fails. Or maybe it doesn't, who knows. Anyway, this bit of code isn't mission critical because it just runs once at the start of the program, and it's not doing it at runtime. Okay. Great. So the other thing we have is collision detection. So when we look at the player, we have the player's update function. And if we're pressing forwards, up or down, forwards or backwards, we want to move the player, but the collision detection code is a bit much, so I put it in a separate function called move. No problem. We look at move. Now what we do is if we check each collision detection independently, the X component and the Y component. So if moving in the X component would put us into a wall, then just double checking my own code. If moving in the X direction would put us into a wall, then simply don't move in the X direction. And this has the effect of approximating a nice sliding action. Yep, so we have this could move to. That's the point that we want to check. We don't move there yet, we just check it. Okay, and then we look through all of our walls and we test against each of our walls. And then if any of them fail, then we set this can move as false and break. Okay, no problem. But on the other hand, if we can move, then load that X component of movement into the temporary, movement amount. And then at the end, move by however much we can move by. So if both the X and Y tests failed, the player would not move at all. Yeah, okay, great. So let's check that lines intersect. Okay, so this is kind of hard-coded, right? So this is saying the player wants to move from one point to another, and the wall spans between another 2 points. Are those, is that movement going to cross through the wall? So I've kind of cheated a little bit. So in my game, I'm only going to have vertical and horizontal walls. That simplifies the testing quite a bit. So first we check whether we're dealing with a vertical or horizontal wall, okay? And I'm just going to go through the vertical wall because the test goes the same way. So if we've got a vertical wall, just, get our upper and lower Y values. Great. And, in the case that we're moving completely below the wall or completely above the wall, then no problem. We don't have to test anything else. So here are my points. If I'm moving from here to here, that's above the wall. Great, no problem. If I'm moving here to here, great, no problem. It's if one of the points is within that range of the vertical wall, then we need to check things, okay? So we get the X coordinate of the wall, and this is a bit of a trick here. So let's imagine a wall, and I'm on one side of the wall. So my X difference to the wall should be positive, say, or negative, it doesn't matter. And then if I cross through the wall, if my X distance was positive, then it would flip to negative, or the other way around. And when two numbers change sign, multiplying them will always give a negative number. So that's my test here to see if we've changed orientation through the wall, if that makes sense. And there are some other ways to do this, which I'll maybe look at in later videos. But that's it. That's a lot of talking, and as we can see, it works. So it's important to to try out a bigger system, because there is a kind of emergent complexity that you don't see with a little example. For instance, and I did this because I was hoping that I could tank the system, I've got 67 walls. Now, collision checking against 67 walls is a bit much. It's pointlessly wasteful. However, if I uncap the frame rate and play this, it's playing at about 500 frames per second, even recording this at the same time. And on the system that I developed this on, which was a bit less powerful, it was still, all that wasteful collision checking was still not penalizing it that much. So that's interesting. But anyway, that's it for now. Thanks for checking it out. Have a good day.